We're on page 27 in the notes. Last time we started talking about the standard normal distribution. I want to just review what we were doing at the end of class last time to make sure that the new stuff we do today makes some sense. A standard normal distribution is just a normal distribution with a mean of 0 and a standard deviation of 1. Standard normal distribution is a normal distribution with a mean, and because we're dealing with a population, we're going to use the Greek letter mu, mean of 0, and a standard deviation, sigma, of 1. If we go and try to fill in the tick marks on our graph below, I've got 0 in the middle for my mean. 1 standard deviation to the right just puts us at 1, and then 2, and then 3. And moving to the left, we have -1, -2, -3. As we talked about last time with the empirical rule, we can still say that 68% of the data is between -1 and 1, 95% of the data between -2 and 2, and so on. But there's a little bit more we can do with this particular standard normal distribution. And in the end, we're going to try to figure out the percent of data between maybe -0.5 and 0.2, and things like that. To figure this out, we need to use the tables that you see in your notes on the next 2 pages, on page 28 and 29. And we already looked at this a little bit last time. The numbers in the table just tell us the percent of data, written as a decimal, that is less than our particular value that we're dealing with. So let me rewrite that one more time. The numbers in the table tell the percent of data as a decimal that is less than our particular value, which we'll just call z. We'll fill in a little more with that later. But looking at the examples on the bottom of the page, we're asked to find the percent of data where all the values are less than 1.15. Well, we're going to go to our standard normal table on the next 2 pages. In particular, I'm going to go to page 29. To read this table, the table tells me all the percent of the population where the values are less than a specific number. In this case, we want to look for the values less than 1.15. I'm going to go to the row for 1.1. I'm going to go over to 0.5. Looks to me like I'm getting a decimal of 0.8749. I'm going to write that one down over here, 0.8749. And then writing that as a percent, we get 87.49%. If we're asked to find the percent of data less than -0.24, well, I'm going to go to my negative table, which is on page 28. And as I think I mentioned last time, you will get a copy of this table for all tests and quizzes involving this stuff. Less than -0.24. So I'm going to go down to my row for -0.2. I'm going to go over to 0.4, and I'm going to see that 0.4052 is the number in the table. Let me write that down, which is telling me that 40.52% of my data has a z-value less than -0.24. I'd like you to take a moment right now and see if you can do letters C and D on your own. In letter C, I want to find the percent of the data where the z-value is less than -2.19. I'm going to go to page 28. I'm going to look for -2.1. I'm going to go over to 0.9, and I'm going to see that the decimal there is 0.0143. And writing this as a percent, we get 1.43%. In letter D, less than 2.17, well, I'm going to go to my positive table, 2.1, and I'm going to go over to 7, which looks like over here, 0.9850, which tells me that 98.50% of the data is less than 2.17. However, sometimes we want to find the percent of data less than a specific value. Sometimes we want to find the percent of data greater than some value. And sometimes we want to find the percent of data in between two values. Well, there are some variations on this that we can use to figure out those calculations. Before we go on, there is one other thing that I do want to make note of under the section that says using the standard normal table. The total area between the curve and the x-axis, if we go out forever to the left and the right, and we were able to actually find that area, the total area will be 1, which should make a little bit of sense. 1 as a percent is 100. 100% of your data is contained below the standard normal distribution. I just want to add in here that the total area between the curve and the x-axis is 1. The total area between the curve and the x-axis is 1. Let's move on to page 30. We want to now find percents of data less than specific values. We already talked about that. Greater than specific values, and then in between specific values. First of all, if I want to find the area to the left of a particular value, let's say my normal distribution looks like this, and my particular z-value is over here, and I want to find the percent of data over here, which will just be the area underneath the curve. All I'm going to do is find that area in my table. Because that's sort of the whole point of that table. That table gives us the area, the percent of the population, that is less than a specific z-value. Well, we're looking for the area less than that specific z-value, so we'll get that straight from the table. If instead we want to find the area to the right of a specific z-value, here's my z-value. Let's say I want to find the area to the right. Keep in mind that the table only gives us areas to the left of specific z-values. I could look at the table and I can find the area to the left of this thing. But I want to get the area to the right. Well, hopefully you remember from what we wrote just a moment ago that the total area underneath the curve is just 1. Therefore, what I can do is I can find the area to the left, this area over here, and subtract that from 1 to get this shaded area to the right. What we're going to do is we're going to use the table to find the area to the left of z, then we're just going to subtract that from 1. We're going to use the formula 1 minus the area to the left of z. The total area is 1, so if I know this area, all I have to do is subtract that from 1 to get my area that I actually care about. But what if instead we want to find the area in between two z-values? Well, let me draw out a normal distribution. And I want to deal with between z1 and z2. I want to find the shaded region between those two. Well, the first thing I'm going to do, because keep in mind, the table just tells us the area to the left of a specific value. I'm just going to find all the area to the left of z2. Find all the area to the left of z2, and I'll just get that value straight from my table. And once I've found that, I will know this entire shaded region, which is a little too much, but at least that's a good place for me to start. But I just want the area between Z1 and Z2, not the area that's to the left of Z1. Well, all that I need to do is find that area to the left of Z1, which I can just get from my table, do some subtraction, and I'll be left with the area in between. The next thing I'm going to do is find the area to the left of Z1. Let me find a color for this one. Let me shade this in over here. And I want to take that green area away from the red area, and I'll be left with the piece that I want in the middle. And we're just going to subtract those answers. So this is the basic idea. Let me show you some examples and see what happens with this. Let's go on to page 31, and I would keep page 30 handy as a reference as we go to do this. Letter A is nothing new. Letter A is what we were doing before. I want to find the area to the left of negative 0.99. Well, let's just go to our standard normal table over here. I want to find negative 0.99, so to the negative 0.9 row, to the 0.9 column. Hold on one moment. Oh, I can't do that. Never mind. Negative 0.9 over to the 0.09 column, and we're going to get 0.1611. So our percent of data over there, just 16.11%. Again, this is nothing new. I'm going to let you try B in a moment. Actually, forget about that. Go try B right now. This is still nothing new. I'm looking for the percent of data that's less than 2.13. I'm going to go down to the row for 2.1. I'm going to go over to the column for 0.03, and I'm going to get 0.9834. Turn that into a percent. 98.34% of our data has a z-value less than 2.13. Moving on. Actually, I don't like that at all. We're going to try this whole thing again.